Okay, square is inscribed in a circle of radius r. To find the area of the square BCDE. So the BCDE, they want the area of that square. Okay, so let's just pull that shape out. Now we're told it's a square, so we know all the sides are the same length. So if I wanted, for example, to find one of the sides, now look, they really want this in terms of r. Sorry, 1 second there. So let's create a right angle triangle that we can work with. And because this is a square, when you create diagonals, they cross each other at right angles. So that means this is a right angle here. So what in essence I have up here is I have a right angle triangle where I know two sides, but I need this length, which is the hypotenuse opposite the 90 degrees. So the hypotenuse squared equals r squared plus r squared. So h is equal to the square root of 2r squared. So that's going to be each side of my rectangle will be that, or each side of my area of each side of my square would be that length. So here's my square, that's root 2r squared and root 2r squared. So the area of my square is length by width, root 2r squared multiplied by root 2r squared. Okay, and that's just going to give me 2r squared. Okay, so we have to find now in part 2 the shaded area up here. So if I look at it in terms of a sector first, I'll find the area of that entire sector. Now what's the angle at the center here? Well, I know that angle at the center is 90 degrees. So the area for the sector of a circle is pi r squared times theta over 360. So area is equal to pi r squared times theta, which is 180 over 360. So the area there is equal to pi r squared over 2. Now I need to take away the area of this triangle. Okay, what's the area of the triangle? Well, it's exactly 1/4 of the square. I know the square is 2r squared. So 1/4 of that is 2r squared over 4, which is just r squared over 2. So the shaded area is just going to be pi r squared over 2 minus r squared over 2, which is just going to give us pi r squared minus r squared over 2. And that's the shaded area in terms of r.